Alright, AP Stats students, this is going to be a quick summary on section 1.2, as promised. I know that the buzz going around school right now, you walk through the hallways, you hear a variety of conversations going on, what the football game coming up this weekend, what movie's out, or music is popular right now, who's dating who, things like that. But probably the most talked about topic right now on FRHS's tongues are uh, is the topic of displaying quantitative data with graphs, right? So everybody's excited about that, and I'm excited as well. And I'm glad the wait is over, and everybody can sleep happy now. And that's what we're going to talk about in this video: displaying quantitative data with graphs. So let's get to it. I will go through this pretty quickly, so you can pause if you need to stop and take notes, but we're going to talk about first dot plots. So here's a data set. We should all know how to make a dot plot, and here's a data set of soccer goals scored by the U.S. women's soccer team. Notice the things I want to point out. Notice it's labeled, what's important, how it's scaled, right, and scaled based on the range of the data. And we can talk about shape center spread, which we will get to in the next slide. So what we talk about when we have graphical representations of quantitative data is shape center spread and outliers, right? SOCs. So shape center spread is going to be a given each time. That will be talked about in each distribution you see. Outliers just is dependent upon whether they actually are present or not. So you want to ask yourself, what do I see at the beginning of a question? If it's asking you to compare distributions or look at a single distribution, you want to talk about shape center spread and outliers. Here's an example. Let's do it real quick. We can talk about the shape, right? This is going to be skewed to the left. This is of cars, mid-size cars, model year 2009, and their miles per gallon, right? Our shape would be skewed to the left, so you'd say the distribution for mid-size cars year 2009 is skewed to the left. We would say our center is at 28. That's the median. You can get that just by counting to the 12.5 observation. And so we would say typically mid-size cars year 2009 have 28 miles per gallon. Spread, that would be from 33 to 14. So this distribution ranges 19 miles per gallon. And then outliers, this 14, which is the Bentley, is a potential outlier. So that covers, I think, all four. So let's move on. When we talk about shape, we use key terms like symmetric, skewed to the right, skewed to the left. We went over these in class. These are what these distributions look like. Typically, you're not really ever going to have something perfectly symmetric, so we use words like roughly or approximately when describing it. If something is slightly skewed, we say that. If it's extremely skewed, we say that. So using words like that, I guess those would be adverbs, are helpful. And let's move on. When we're comparing distributions, so we did this in class, right? This was a problem you had when you came in one day. And how we would compare these are in terms of shape center spread. I'll give an example of center, right? So I think the median for this was 5, and the median for UK was 4. So a way we would compare that, you don't want to say, well, the median for South African household size is 5, while the median of UK household size is 4. That's not comparing. You're just talking about one and then the other. You want to say typically, when we talk about the median, we use the word typically. When we talk about the mean, which we'll learn about in 1.3, section 1.3, we say on the average or average. But when we're talking about the median, we'll say typically UK household size is less than South African household size. That's the comparison right there of center. You'd want to give the medians. So the median of 4 for UK is less than 5. Therefore, typically, UK households have less people in their households. So You can do that with shape and spread as well, right? Spread for South African household is much larger than UK. We can see that. The shape, South African distribution is much more skewed to the right than the UK distribution, which is roughly symmetric. So let's move on. Stem and leaf. So here is you can pause this if you want to take notes on that. It's how to construct stem and leaf. Should be a review. We have this data set of 20 female AP Stat students and how many pairs of shoes they have. So we choose our stems. Remember, those are the first digits, like 1 and 5, 3, and then the leaves are going to be the second digit. We order them chronologically, as we have done here, and we can make sure that you label your graphs, just like you'd label your x-axis on your dot plot. You would provide a key in context. You don't just say 49 equals 49. You have to say 49 and what that represents. It represents 49 pairs of shoes. You can get shape center spread from this as well. So splitting terms, that's if we have, so usually you split terms when you have larger data sets because they get bunched up, the values get bunched up, and you split them like this, right? This would be from 0 to 4. This would be from 5 to 9. And then 11 to 14, 15 to 19, 21, 24, so on and so forth. You split the terms. This actually is one where if it's not the best example. Usually you do it with a much larger sample. This is just a sample of 20. When we have a larger sample, a lot of times the values are going to get bunched up. So these might actually go out to like here or here. And if you split the terms, we might see something like a gap, like right here or there, that doesn't show up when we bunch them up. So that's why we would split the terms. You can also do back-to-back stem and leaf plots. So we have males and females here. We can compare those to one another. We could say, let's do center again, just to remain consistent. The center for this should be somewhere in here. The center for this, I guess, is probably right around here. And it'd actually be right here. And we would say typically males have fewer, based on the median, right? Typically males have fewer pairs of shoes than females, which does not come as a surprise, right? We could compare shape, right? This is going to be skewed to the right. This is going to be roughly symmetric. So we would say the male distribution of how many pairs of shoes they have is skewed to the right, or much more skewed to the right than the female, which is roughly symmetric. So spread as well. The spread is much larger for females than it is for males. So that's just from the range, right? 75 to 13 is much larger than 38 to 4. So it's actually about half the size, like 62 to 32. That's almost double. So let's move on to, oh, notice, let me go back real quick, the keys. Once again, labeling your graphs, providing a key. In context, 49 pairs of shoes. So last is histograms. So this is how you make a histogram. The weird thing about histogram is it looks like a bar graph, but it's not. We divide it into classes. So you might have, if you have a class from 0 to 5, it's going to be all the values that fall into that category. We have counts, which the example we'll use on the next slide are counts, and then we can convert those counts to percents, and I'll show you how we can do that. And those are in terms of frequency and relative frequency. So we'll talk about that a little bit more in a sec. This is data from page 35 in your book. I think it's all 50 states and like the percentage of people that were born outside the United States. So these are counts. So these would be frequencies. So 20 people or 20 states had a percentage of 0 to 5, 0 or less than 5%. So I guess 0 to 4.99999% that were born outside the U.S. This would be 5 to 9.99999. So 13 states fell in that category. And when we would graph these, notice these widths. So from 0 to 5, there's 20. From 5 to 10, there's 13. 10 to 15, there's 8, or 9, sorry. So those are the counts. If we wanted to convert these to percents, we could do that easily, right? We have the total, 50 states. So 20 over 50 would be the percentage, right? Which would be, I think, 0.4. So 40%, so we can convert our counts to percentages relative, so frequency to relative frequency very easily. This would be 13 over 50, which would be 20.26. 9 over 50, which should be 0.18. And you get the picture. And so on and so forth. These percentages should add up to 100. So you can graph, you would just change the scale over here on your y-axis to percentages. So 40%, 26, 18. This would be 10, 0.1. This would be 0.04. And this would be 0.02, right? Sorry for the bad handwriting. So that's how we would go from frequencies to relative frequencies, and you can graph those. Relative frequencies, we're going to talk about it right here, are typically better. So percents. When I say relative frequency, I mean percents. When we compare distributions, you want to use percents because we might have different sample sizes. You might have one sample of 10 and one sample of 15. So the percents are going to be off because of the difference in the sample size. So or the counts. Sorry, the counts will be off. But the percents will not. They're a better representation when we are comparing graphs. All right, so I think that covers it. So here's just kind of a summary of what we went over in this lecture or in the summary video. Hopefully this will help, and I will see you guys in class.